Let's graph the cotangent function now. The cotangent function is very similar to tangent, but it's different. And we'll compare them as we go along, and we'll talk about how you keep the distinction between the two. You don't want to get them mixed up. The way we graph tangent is very similar, the way we graph cotangent is very similar to the way we graph tangent. We want to remember that cotangent x is always equal to cosine x over sine x. And so it's the reciprocal of tangent, right? Here cosine is in the numerator, sine is in the denominator. So cotangent will have x-intercepts where cosine is equal to 0. And since sine x is in the denominator, it will have vertical asymptotes where sine x is equal to 0. Just the reverse of tangent, in a sense. Now, again, we're going to rely on our knowledge of the cosine functions to help us out here. And I'm going to label my horizontal axis pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and the negative direction. Negative 2 pi. And, okay, so x-intercepts were cosine 0. Cosine 0 at pi over 2, 3 pi over 2, 5 pi over 2. So these odd multiples of pi over 2, both positive and negative. That's where cotangent will have its zeros, will have its x-intercepts. Its vertical asymptotes occur where sine is 0. And that's actually at 0. The y-axis is a vertical asymptote to cotangent. And at pi, at 2 pi, so at all the multiples of pi, negative pi, negative 2 pi. So cotangent has vertical asymptotes where tangent has x-intercepts, and it has its x-intercepts where tangent has vertical asymptotes. Now we got to fill in the branches of the graph. And here it's real easy to make a mistake. If we think about pi over 4 and negative pi over 4 again, the cotangent of pi over 4 is the same as tangent pi over 4. It's positive 1. And the cotangent of negative pi over 4 is negative 1. Now, the graph does not pass through the y-axis here. These points just help me see that if I back up from pi over 2 to pi over 4, I gotta be rising up along that a vertical asymptote on the y-axis, and to the right, I have to be going down. This negative 1 point at negative pi over 4 helps me see that I have a shape like that, and then I repeat these branches over and over again. Cotangent also has a period of pi, just like the tangent function. But if you want to contrast the tangent and cotangent, and they do look very, very similar, just note that the branches of cotangent are all decreasing as you go from left to right. If you were to graph tan x, the branches are all increasing as you move from left to right. If we compare our previous graph at tangent, all these branches increase from left to right. distinction helps me keep from accidentally mixing up these two. The domain of cotangent is also a mess, just like with tangent. It's a little bit easier to write down because it's all real numbers except the x values where the vertical asymptotes occur. So that's except 0, plus or minus pi, plus or minus 2 pi, so on and so forth, the multiples of pi. And in interval notation, that would be 0 pi, union pi 2 pi, union 2 pi 3 pi, so on and so forth. Also negative pi 0, union, on and on in the negative direction. So still a mess to write down. It's all x values except where the vertical asymptotes occur. The range of cotangent is all real numbers. Just like with tangents. So its range is actually fairly simple to describe. The period is pi. So both tangent and cotangent have this shorter period than sine and cosine. And cotangent is also an odd function. So while its graph is in a slightly different position from tangent, if we turn the graph upside down, we have exactly the same shape. And it is not one-to-one. And again, there is no amplitude, as we've said with tangent. It makes no sense to talk about amplitude with tangent or cotangent. So there's the cotangent graph.